Yes. Huh? Okay. So we will be discussing in our today's discussion. We'll first go through the very brief of the artificial neural network. It is a prerequisite of what we are intended to understand about a little bit about the deep learning, because our final motive is to think of the AI vision as a tool for smart manufacturing. So that is what we are trying to do sequentially so that you can recapitulate what this artificial neural network is. It's a basically artificial learning processes. And you must be knowing that in any engineering problem, science or engineering problems, there will be some independent variables and a number of response variables are there. So there is always some kind of relationship, hidden relationship between the input variable and the response variable. The issue is that quite often in the engineering arena or the scientific arena, these relationships are non-linear, and capturing the non-linear relationship is a little bit uh, problematic issue. Now, what people have been doing since before say 30, 40 years, uh, the conventional statistical methods, linear regression, all those things they used to do to explore the relationship between the input and output. Multiple regression and all those things were also there. The issue is that whenever we go for the regression analysis, we have to have some preemptive assumptions, which may not always be workable. And the relationship can be too complex to be modeled in that way. So whenever that is there, then the mimic, by way of mimicking the human learning techniques, the new generation artificial learning has been invoked, and that is in the form of neural network, which maps the input output relationship from a known set of data. It's basically a supervised learning. Learning can be supervised, learning can be unsupervised. In the computational uh, language, you can say that the supervised learning will be someone where the correct information is with us and we can compare with that. The actual information is there, so we can compare with that. And when the data, available data is unstructured and we do not have any reference to compare, then naturally the feature extraction can be there, and by that we can identify. The pattern recognition is essentially the thing which is done by this neural network. So this kind of the neural network architecture, uh, yeah, yeah, the pointer. So नीचे से third one. Yes. So you see that this is a typical architecture of artificial neural network. How do they do that kind of learning? That that this is these are the different inputs. The different inputs. So this layer is called the input layers, and these are the nodes or the neurons. And from here, this data will be uh, given to be transferred to the different kind layers. This is one hidden layer. So what happens is that here one particular data is multiplied by some weight, arbitrarily chosen weight, and then it is transported to here. Similarly, some other data is done like that. And then here, the entire weighted data is summed up. And then that is with that, another bias value, that is another arbitrarily chosen value is added. And this value is now given to pass through some kind of universal approximator. That is called the transfer function or the activation function. And then that comes in here, and ultimately you will see that this node is connected to all the inputs, and then this node is connected to all the inputs. So everywhere the input value is different, and this input value is from 0 to 1. I'll show you one particular example. I'll show you. So, so first of all, you have to understand that the different input values, they are multiplied by some weights, arbitrarily chosen weights. I do not know what is the weight, and then once it comes here, all these things, they are again summed up, and then that is added with a bias, and then it is compared with the original output. So once that comparison is there, then there will be a difference, and then the difference of if there are 100 data, so 100 such differences will be obtained, and then this root mean square value of these differences will be calculated, and then this calculated value will then be compared with the given out given output, and then either it can be lower than the given or it can be higher. So once that is there, then in accordance with that, it will be back propagated here, and it will again restart its operation. And so restarting the back propagation and then once again starting, that is called one iteration or one epoch. So this is how it will continue to adjust its weights and bias values till the time the error becomes, the error means that the difference between the modeled value and the actual value, when the error becomes minimum, then you can say that okay, this is the final structure, and then from that it can be expressed, it can be saved in the form of some equation. So that becomes a relationship. So that is a technique. That is a technique uh, mimicking the human learning. So the ANN variables are the number of iterations. I have already told you, number of hidden layers, number of neurons in each layer, topology, and the general observation is the training error decreases with the number of hidden units. Now let us go to here, so that we can understand the things. You see that, suppose this is a, I have taken the example of a steel which has got different composition, and it is also given to be treated differently, annealing, temperature, and all those things, and it has got some output value like yield strength or tensile strength value. So this is the value, and this is the composition, the minimum of these elements, a chromium. Minimum is this, maximum is this. Its mean value is this. And then what do we do is that this is the value. And then we have huge number of such values. So minimum value and minimum maximum, within that I have say 200, 300, 500 samples. So naturally I have 500 such data sets. So for each data set comprises of this value as well as this is the response variable. And then what we do is that, let us go back here, and then we find that here all those values are put here, and then these values are normalized to 0 to 1. So these are normalized to 0 to 1. Normalizing means that it is basically the maximum value. I'm showing you that the observed value, maximum value minus the observed value, and divided by the maximum minus minimum. So that is always be like that. You see, this is the normalized value. This is the normalized value. You see that this is a given value. This divided minus your minimum value and maximum minus minimum. This will be within 0 to 1. So this is a normal way of normalizing the value. So for all these things, different sets of values will be there, and then you will be finding that different kind of such values are there, and then this normalized value you will be taking, and then from here you will put those things here, and then after that you will give the weights, adjusted weights, and here the transfer function is there. That means this is something which I'll tell you that what is the mathematical operation they do here. You see that from each and every node, the value comes to a particular hidden node, and then it is multiplied by some weight, and everything. All these things are summed up, and then this sum is added with some bias value, and then this bias value, once this is there, then this is the value of the jth, or for that matter, any of the hidden nodes. Say first hidden node, j is equal to 1, say, and then this value is given to pass through one function. This function is the approximator. That means as if the compositions are related with this functional relationship is there with the your output value. So naturally you will be getting this value. So the output will be like this, and then once this output is this, then you can really compare it, and ultimately you can get it. Now what you find from here is, I will not go in very wide details. I will simply tell you that these are the variables, and then you see that here this is fixed. You cannot do it. What you can do is that this is the number of layers you can increase. You can increase the number of nodes in a particular layer, and then in accordance with that, the architectural topology can be changed, and then accordingly you can see that these are all variables. And another variables are there, that is that the weight changing. Weight is generated by a random number generator is there in that your software, and then because of that, this random value, then what will be the next value of the random number. So that step is also to be given in that input as an input. So the step size, that means the once the random number x will be changed to x1. So the difference, how much multiplied factor will be, multiplication factor will be there. That is your way. So therefore, you can see that these are the things which you may not understand right at this moment. You see that the total number of neurons, taking all hidden layers in consideration, if we increase the number of neurons, then you find that the training error will be gradually reduced. So this is the kind of experiments which one of my students has done it. And then you see that as the number of hidden layers is increasing, then the error is increasing. So that is the reason why in today's scenario, the neural network is done with a single hidden node. Whereas number of hidden nodes, if you increase, then as you could find that the uh, um, complexity of the analysis increases. So that is something which I'll be coming as a different form. So in normal artificial neural network, we are using the architecture like this. So a single hidden node we are using. So up to that, let us take it accepted, and then you see that different layers, if you vary the number of neurons or number of nodes, then again you find that as you are increasing the number of nodes in most of the layers, you will find, but except for some of the layers, their behavior is not that. I mean, initially, right at the initial stage where the thing has not been equilibrated, there you can find that this kind of situation may occur. So what is important from here is that here you find that number of neuron number in different layers. You find that there is an optimum value of neuron numbers in almost everywhere. You find that between 15 to 20 neurons will be good for a particular problem. This value can be changed with a different problem or the different number of data. So in fact, whenever we describe any neural network, we do it like this. We describe it like this. That one means that this first case, and then you find that this is how the number of neurons in different layers, that is how it is moving. So this is the thing, and this is the output layer. One is the output layer. So naturally, you can really find that available error. What I try to tell you is that once you change these values, that inter layer neuron distribution, once you change, then you see that the error gets changed. Whatever be the thing, ultimately what purpose is that you have to reduce the error value, and for that, what you have to do is that after you train those things, you'll be getting one particular relationship, and with that relationship, you can find out the actual, uh, actual. You can put those data, and you can find that actual relationship. From there, you can say whether your model is correct or not. Here, we have taken the actual value of chromium and instead plotted it from the data as predicted by the neural network, and then this kind of relationship is there. The physically, we have got this kind of data, and we can ultimately tell whether the model is good or not. So this is the thing. And then there are again different workers are there, where the your optimization of the hidden units are there. So but since I have already told you that it is a matter of experience, by that it has been frozen to in number one hidden layer, so it will be like this. Now what is important here is that you see that the training time, with the training time, the number of iterations, if you change, then ये थोड़ा छोटा करना पड़ेगा, दिखा जाता तुम देखो। हम्म, So you see that these are the results. I mean, I'm not really interested to describe it here, because you may not find interest in that. So here you find that when you get the trading, then you can get the trading curve like this with the number of hidden units. And these some values, some of the data you have to keep for testing your model. And once you find that this kind of matching is there, then you may say that okay, your training is perfect. And because you are training the your model, and once you can train the model, then the computer learns the pattern, and once it learns the pattern, then it can reproduce with the unknown values. So this is the interesting thing, but it can reproduce the unknown values within the range of values you have created that model. So that is important. This is how a neural network is described. Like suppose the number of input is 9, so it will be 9, and then hidden layer neuron number 15, 10, 15. So three hidden layers are there, and this is one output layer. So this is how one artificial neural network is written by this. And uh, these are the things. I mean, normally you can change these things, but normally whatever number of hidden units you write here, this is fixed by the number of input variables. This is fixed by the number of output variables. It can be one or two, uh, and and here you can find that it is up to you. This is an independent thing which you can vary, and you do not require it for a classical conventional neural network. But for deep learning, you will be needing this. Now, this is another story where you will see that the connectivity is made biased. Connectivity is made biased, and by that, individual elemental effect on the property of a material could be managed. So, therefore, if you know very well, physically, if you know that out of all these variables, some of the variables have got some kind of interdependent effect on the final response variables, then you can make the connectivity biased. So that is what it shows in here. Now, without going in any further there, you see that the biased connectivity means that here not all the inputs are connected. Here only some of the elements which are responsible for this phenomenon, so that those are connected here. And here some of the factors, some of the input values which are responsible for this thing, uh, these are connected here. Now it is taken for a particular material, and even if you are not a materials man or mechanical engineer, if you are something someone else have expertise somewhere, so the generic statement is some input layers are there and then the hidden layers are there. If the hidden layers are phenomenological hidden layers, then the input the individual inputs will have effect on one or more of the uh, phenomenological uh, issues. So therefore, what you can do is that you can make the connectivity in accordance with that, thereby making it a biased connectivity. So if you do that, that has been shown here. So by that you can make the neural network expert, a little more expert. So that is called the expert neural network, that was given this kind of name. So most important part is this. I have already told you what is happening here. That all the input values, they are multiplied by some weight values. Weights are arbitrarily chosen and different weights are there for all these limbs. And so the different weights are there, and then after that they are added with a bias value. And then these things are passed, are operated by a mathematical function. So this mathematical function is the universal approximator that is ultimately approximating the relationship between the input and the output, because here it is acting as a summer only, nothing is there, it is only adding those things and then give it straightway to the output value. So therefore it is just as a summer, it is acting, so naturally it does not have anything else to do. By that, the effect of individual phenomenological issues we can find out. We can find out. And the entire mathematics can be written by that. Here, the tan hyperbolic function was used. You see that the relationship will be like this, that the output will be tan hyperbolic of function of summation of these value, the weight values of jth node and the actual value, input value of the jth. So this is how jth node means that any number of node, x node, y node, whatever you can say. Now, so we will be summarizing very quickly here, because that is not, I mean, that was just to give you some idea that what we are doing, that what is happening, that here some input layers are there, some input values are there. So these input values, they are multiplied by some weights and added by some bias values, random values, and then these are taken here. All these input values, they are given the same, sending the same kind of thing, or but the weight values are different, input values are different, because the original values are different. I have shown you one example. So naturally, once they come there, then all these things are summed up. They are weighted values with the bias. They are summed up, and after summing up, they are operated with a mathematical function to be chosen by you. And then, since this is known, I mean this is the output value, and then this is the calculated output, and one output value is already there for this set of data set, experimental value. So you basically compare this, get the difference of error, and these values are more than 500, 600 values. So all these 500, 600 differences you will be getting, and then differences, the square of those differences, and then mean root of that differences will be the value which will be read by the software, and then to minimize that value, that is called the error value. So to minimize that value, it will be back propagated here. So the algorithm is a feed forward back propagation algorithm, feed forward network. That means it again starts from here. So it is feeding forward, and then once it comes here, then again it is back propagated with the information, and then accordingly the weights are adjusted. So this is how it will continue, and each particular cycle is one iteration. So it will continue till the time this root mean square error is minimum. And the way it is done, the way it is going, I have shown it here that gradually it is reducing, and you have to truncate that. So many issues are there, you can think of that. Now, I have already told you. Now, here, the hybrid modeling is that artificial neural network is like a black box. It does not know what is the reason behind the physical reasons are not understood by the neural network. It is just as if uh, some pattern is being shown to it regularly, and by that it learns the pattern. So the if overlearning is there, then it will simply learn that say only that pattern. So the similar type of pattern it cannot recognize. So that is called the overfitting of data. Overfitting of data. So naturally you have to find out very judiciously. You have to carry out this model, and then you find that sometimes the is that the understanding these things, people can hybridize this ANN modeling with other things. How? That they can hybridize it with some physical model. So the physical model is there. I mean, any science, scientific or engineering science. So it can have that physical model, and if you integrate that physical model with the neural network model, then you can find that these are the physical models, and you are integrating this in a neural network model. Then these are the physically based idea, and neurophagy I have not discussed. So naturally, but this one I want to discuss. That whatever I told you, that there has to be some approximation, that some mathematical function has to be operated. That those values at the nodes, they will be operated with some mathematical functions. So those functions are called transfer functions. Many such transfer functions are there, and then we use the tan hyperbolic function. So we use the tan hyperbolic function, the a sigmoid function, actually logistic function, and then as you move upward, so these functions are more universal. So these are called the universal approximator, and uh, most of the softwares in the MATLAB or in other, up to this is there, but you can also take this kind of complex transfer function in your, you can write codes, and you can do your own neural network modeling, and you can do that kind of thing. You can do that. Now, once we have a very basic preliminary idea of this thing, we will come out from here, and then we will uh, go to understand. कहाँ चला गया तू? Oh, ये होगा? Is it? Can they see it? Yes. Now, you see that this deep learning is a kind of artificial neural network. Here, as I said, that if in an artificial neural network, only major difference is that this deep learning is normally accomplished with the data, the graphic data, because otherwise the normal uh, data can be effectively handled by the neural network. But unless we make the network a little complicated, the deep learning basically a neural network learning, but the neural network learning is but learning through neural network, more than one number of hidden nodes, two or three or more number of hidden nodes will be there, which is a constituent of the deep learning. It is a subset of machine learning and the multi-layered neural net. So basically, it mimics the structure and function of human brain. I have already told you. Now, the key difference between the deep learning is that the large amount of unstructured data sets it can learn automatically, which is not given to be done by the ordinary neural network, where we normally prefer to carry out accomplish the supervised learning. So here the deep learning unstructured data sets, large amount of unstructured data sets, because large amount is required because it has to find out the features and the feature extraction, and then ultimately it has to learn, and it can take a decision. So if I go through the history and evolution, then we will see that 1950s first the perceptor concept is there. That means something is there, and the comparison of that learning started. And then between 80s to 90s, neural network research gained importance. And then around 90s to 2000, there was a very good research in the neural network of the engineering areas, the control engineering, materials engineering, and all those things. And then it basically breaks away from the computer science as such. And then it started being used extensively in the other engineering fields. And the computer science was trying to develop it. And then in 2006, the breakthroughs has been there with the graphic processing units. When the graphic processing units could be used, GPUs could be used for neural network, there was a breakthrough. And that breakthrough was possible because of this deep learning. And then 2010 onwards, there has been the big data analysis that has been there, and the hardware system was accelerated for accelerated deep learning. So the core concept, deep learning is essentially artificial neural network. And then here again the same hidden output layers, more number of hidden layers will be there. Then again the activation functions will be there, like tran, hyperbolic, sigmoid, ReLU, all different functions can be there. Training through feed forward and backward, feed forward and back propagation. Backward propagation or back propagation. So same thing. Now this is the architecture, the input layer, there is a hidden layer one, the same thing. You see that the same thing which I have discussed here, all these inputs are there, the same thing has happened, the similar thing, that's addition, transfer function, this transfer function and this transfer function can be different, can be same also. So it is all dependent upon you. So what you will do? So I mean, then ultimately output, then the training, that means the training means that go on minimizing the error. So this process is called the training. So after training is completed, some data, untested data will be there. They will be put in there. That is for the testing. If I find that the testing gives you the similar error, then the network is complete, good network design, and then after that you can validate with another 15% of data. So what are the steps? The first step is the data processing. That whenever the data enters the input layer, then they pass through the hidden layer. So the data processing has to be there. So the data has to be refined. And then the feature learning. Feature learning means that the human defined features will not be dependent upon. Here the deep learning models automatically learn features. It will find out the feature which is to be taken, and then it will find out that it will learn the features from the data itself. So that is why it is unsupervised learning. So that is why it will find out the feature, and then that feature, because I am using the graphic data. So graphics data I am using. Suppose a picture I am giving. So the picture, from there it will find out a definite feature. Now from the picture, how will it do? That is a separate thing. That is an image processing technique has to be there. Now the deeper layers build upon the features learned by the previous layers. What do they do? Why more number of hidden layers? Now the first few layers will be extracting the features, and once the features are known, then they will understand that this is a feature, and then they will recognize the feature, and then they will say, okay, enough. Then that will stop. So naturally it will not. If you, even if you go on increasing the layer number, then you will see that the error gets disturbed. So, and the iteration and improvement is there. That the iteration I have already told you, that the minimization of error and self-correct it will do. So how humans learn from experience and improve their performance with the more data. Suppose I just give you one example. Suppose you are given one mango leaf and you are told that this is a mango leaf. Now, there can be thousands and thousands of mango trees across the uh, country. And then everybody within the same tree, you will find that any two leaves may have slight difference. And then if the difference is quite perceptible, you may be a little bit confused unless huge number of such mango leaves I show you, and then you can immediately say any other mango leaf which I have not shown you, you can say it is a mango leaf. You will not say that it is a something else, the guava leaf. You will not say it. The reason is that you have already trained. Your brain has trained yourself with that graphical data, with that image, the image which you have built in your brain, and then with that image you have processed that image, and then you know very well. So the similar thing it does. The large number of data. So that is why whether you will be able to go for a good deep learning or not, that will depend upon the data, quantity of data and the quality of data. So if the quality of data is too variant, so naturally there it's a good possibility that it will land into a wrong decision. You see that different sources, they are sending the data, the raw data, and then this data has to be cleaned and transformed. That means that data has to be cleaned and transformed. Transform means that image processing has to be done, and then the features will be extracted, and then with that feature extraction, that has to pass to the model, and then insights will be created. So that is what is the job of a deep learning. The popular architecture of deep learning is convolutional deep learning networks. So they basically, convolutional means that in one particular image, one particular area, it goes into deeper into that, and then it goes on do these things. A recurrent neural network is that one feature, once identified, it goes on uh, uh, recurrent analysis of it. So naturally, that is called the recurrent neural network. And then the transformers can also be architecture, which is the natural language processing or the multimodal AI, and the generative models are also there, the GNs. So these are the popular architecture of the CNNs are quite often used for the graphical data. Key technologies: back propagation, gradient descent algorithm. Gradient descent algorithm means that the error function is there, though if you plot the error, the gradient descent, I mean, as per the error, the way the error is traversing with the increase in the hidden nodes number. So naturally, and the adjustment of the weights. So in accordance with that, the error gradient, according to that, it will descend, and ultimately it will converge to a minimum error level. And the hardware, GPUs, graphic processing unit, and TPUs are the large scale training purpose they are used. TPUs are the is a Google product. It means that the tensor processing unit. So this is specifically designed for the neural network job, that the deep learning. Because deep learning, a neural network that works with a tensor. So that analyzes the tensors. So they express everything in the form of tensors, and that is why the tensor processing units is a better deal. And that's why the Google has introduced this tensor. It is exclusively used for the neural network business. That means mainly your what should I say, that mainly because of this deep learning it is used. And in the frameworks, the different frameworks are used for the deep learning technique, the TensorFlow, because of the fact that this case that is there, PyTorch and Keras. The cloud and distributed computing, You have already exposed to that. Why is it required? Huge number of data is there, so the storage is required, and the distributed computing has to be done so that the data can be handled rather quickly. So it has got a huge application in computer vision because it classifies the images, it can recognize the face, it can image classify the image, it can detect the object autonomously, it can autonomous driving, it can I mean by autonomous driving is possible because of the object detection. And then the medical imaging and diagnostics, lot of things are there, image processing, and then ultimately those things, and the video analysis. Also sentiment analysis can be done. Then it has also got the application in natural language processing. So there, the machine translation, the Google Translator, all those things, the chatbots and all the Google, the GP chat, the Chat GPT is essentially this kind of thing. The chatbots and the conversational AI, sentiment analysis. I've already told you, large language models. The Chat GPT is also this kind of thing. That is a deep learning technique. And then the application in other fields, autonomous driving and robotics, then the financial forecasting and fraud detection, healthcare. Healthcare, it has got a huge application in healthcare because of drug discovery, disease prediction, and then agriculture, crop monitoring, the yield prediction, all these things it can do. So the satellite data it can take and it can ultimately find yield prediction it can do. And what are the advantages? High accuracy in the task, like the vision and speech. Automatically extract features from the data. This is very important. Nobody is to tell. No one has to say. Handles the unstructured data, like the images, audio, text. Scales with more data and computational power. So this is another advantage. What are the challenges and limitations? Large labeled data sets, computationally expensive. Black box, it is black box because the neural network is hard to interpret. Physical modeling integration can be done. That's what I feel, that the physical modeling integration, once you do, then you can make the entire model a little bit translucent. And the ethical issues are there. That the privacy and all those things that can be misused. So once it can be cracked, then it can be misused. So these are the challenges. What are the future trends in deep learning? The future trends in deep learning is that explainable AI for transparency. That means the translucency, as I said, that it will be made more and more transparent. Then edge AI and federated learning, that are cooperative learning. Multimodal AI, combining vision, speech, and text. Green AI, energy efficient training, because the large number of training iterations means that the energy will be spent. In situ defect diagnosis in additive manufacturing. This is what is a point of our interest, because we have discussed this thing with the idea that what is its implication in our basic course FDP, which is your smart manufacturing and industry 4.0. ए, क्या हुआ? हम्म, 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 that's right. हम्म, Now, what we will be doing is that we will be basically that was my job of sharing with you, that the AI vision technology, that is the transforming the industries with intelligent vision system. So that is the idea. Now, what do we do? That AI vision is essentially the artificial intelligence. That is why it is called the AI vision. And the computer vision technology, that means the machines to interpret and understand the visual data. So it will interpret and understand the visual data. So unlike the traditional computer vision, AI vision uses the deep learning models integrated with the computer vision software, the algorithm, so that it can learn the patterns from the data. And applications across healthcare, manufacturing, smart manufacturing, retail, automotive, and more. So this is the thing. What does it do? Now, what are the tasks? That it imitates the human visual system. That means by way of imitating the human visual systems, it can see one image. How it can see one image? That you might be knowing. That many of you can be knowing that the image is basically digitized and then digitized within the gray level 1 to 255, and in accordance with that gray level each pixel 1 to 2 to 255 pixel, uh, so I mean 10 to the power 8 by byte, it is done, and then in accordance with that it can be analyzed at these gray labels. It is expressed in the form of eigenvectors and eigenvalues, and in accordance with that, it is transported and somewhere, and it can be read that way. So basically, computer understands that thing, processes image in that way, and then it record and interpret the image. So that is how, from there, it can interpret the image by finding the commonness, by finding the common features and other things, because it can very easily relate that this particular feature of this image is giving such and such gray levels in such and such pixels. So once it knows that thing, so by seeing that kind of thing, it can immediately say that this is this picture. It can reconstruct that picture. So the deep learning helps in the feature extraction. The way I have told you that once image is there, the image is processed, and the deep learning means that it will ultimately find out what is a feature with which kind of characteristics, the pixel characteristics. So once it knows that thing, so it learns that feature. And then once that feature is learned, then the image recognition is also possible, because from that it can recognize the image. And then once it can image recognize, then it can detect the object. And then this object, if you can have definite data, then it can compare and say whether the newly observed image is a defective image or the correct image. It can process image, label them, and find patterns. So AI vision, image acquisition. First of all, I have to acquire the image. Suppose the manufacturing is going on, and then each step of the processes, the cameras and all the sensors can acquire the images. So the image acquisition is the first step. And then once the images are there, then the images are to be pre-processing. That means the noise reduction has to be done, and then it has to be data has to be normalized. So the normalizing, I have already told you that why it is to be normalized. And then AI ML models, it has to pass through either generative models or the transformer models or the CNN models. So most of the times we will be using CNN for the smart manufacturing cases, and the decision making layer for automation. And there has to be a decision making layer if we want to make the manufacturing autonomous. Key technologies, the machine learning and deep learning, neural networks, CNN, RNN, efficient transformers, edge computing and cloud integration, and the hardware accelerators, GPU, TPUs. I have already told you. Now, key techniques, image segmentation. Image segmentation is very important. Suppose you are giving the image of a data, image data of something where uh, some fruits are uh, defective or are diseased, and then the images of some disease and some good you are showing, then the image will be divided into segments to identify and understand each part. So once it understands each part, then it can find that some difference is there between the good one and the bad one. So once it knows, then once it learns the differences between the bad and good, then once it is told that this is good, then it can always segregate, that it can always classify the bad and the good. It will simply classify the bad and the good, and it will give you the results. So therefore, the object detection, that means for any particular processing, identify the specific objects with an image or video. Once it can find out the objects, then the image can be categorized on their content, such as classifying a picture as a car or a tree or something, or within the image of a tree something else. Now, data processing. AI vision system process the data, digital images and videos to extract information. Algorithms, AI vision algorithms and the deep learning, they are integrated. And the sophisticated algorithms are used for this, and the deep learning models are used to analyze the visual data. That means it is essentially a pattern recognition. So the models are trained on the vast data sets to identify objects, people, or patterns. So then it will interpret. The technology will interpret the recognized patterns to provide useful insights or trigger specific actions. It will say that, okay, this particular image is having such and such features which are not matching with the original. And given the fact that this is like this. Now let us come to a real life example that this AI vision technology, suppose you are capturing the images, online images all the time, and then once you are taking the online images, and then in the computer vision system it is integrated with the entire deep learning and the AI vision algorithms and all those things. So it is processing the images, and then ultimately it is learning, and it is recognizing the object for a particular processing schedule. And then once the processing schedule you are altering, it is again finding the images. So once it finds out that the defective products are coming up, then it can do two things. One is that it can tell you that this is the optimized process parameters which can give you the best results. That means in one end, it can go for aiding in the quality control. At the same time, it can go for the process optimization. Otherwise, what it can do is that if it is also supported by a component, suppose a component we are manufacturing, and the component image monitoring is getting done by the AI vision system, and then also you have fed beforehand some good images, the section images that which does not contain any additive manufacturing the p holes, porosities or something like that, which does not contain. So whenever that is there, then once these data sets are fed, then automatically they can say that this is not good, this is containing porosities. It can be made intelligent because that can be made to learn. With that, we can really train them. So once it gets, we need not train them. The models get themselves trained, and then they can take the interpretation and provide the interpretation that this is giving you the wrong results. So this is the wrong results. So don't go for it. Then if you have the system like this, that it will also actuate the smart manufacturing system, that it will sense, it will interpret, and it will ask the same that through IIoT. Through IIoT, if it can actuate, then automatically it will be automated processing of, it will self-rectify, and it will do the kind of thing. So this is the essence of AI vision. So applications in manufacturing, quality inspection, defect detection, predictive maintenance, automation and robotic vision, worker safety monitoring, that can also be done. That in the workplace, it can also capture the image, and given the safety standard, it can simply dictate, it can give you alarm, it can self rectify. So therefore that is also possible. Not only that, it monitors. So AI vision monitoring of a manufacturing process means that it can monitor any of the other processes too. So the process parameter optimization, defect diagnosis, that can be done. And then this AI vision is a very, very good tool for the security, the wherever a security or any kind of security, it will be very good. And in healthcare, it has got enormous applications. Wherever like the your MRI images and other things, the image processing, the image diagnostics, by seeing the image, it can diagnose what is the disease. It can detect the disease like cancer, eye disorders, etc. It can also assist surgery. Surgical assistance can also be there because of the fact that it always gives you the online data that this is the scenario with that kind of thing with the previously fed data. All hospitals have got. So if the database is there, so from there it can go and compare that no, don't do it, do this way, do that way. And the patient monitoring system can also be done. So these are the things which can be there. In the retail and security, the facial recognition and surveillance it can do. So therefore, nobody can take something and fly back. So because of the security system, it can help the AI vision technology. Customer behavior analysis it can do. Where exactly that customer is going, 10 number of customers is going to that side. So therefore, that side, the materials are there. They are more attractive to 10 number of people. So these are the things. And then the smart checkout systems can also be there. And by that also, threat prevention is a great possibility. By that, you can also do that. In automotive and transportation, autonomous vehicles, the same logic, the autonomous vehicles, the traffic monitoring and safety, driver assistance systems can also be there, and the fleet management can also be there. So, what are the benefits of AI vision? Improved accuracy and efficiency, cost savings through automation. Nothing, the man is not required. Real time decision making. So that's why that Dr. John was saying that the manless vehicle, manless. So all these things they will be using this AI vision. So real time decision making, scalable ac- across the industries. We can scale it. What are the challenges? The challenges are severe. There's a data collection. That's a great challenge. That you have to have, unless you have a huge number of data. With 100 data, if you ask a TPU to do this kind of computer vision, it will not work that way. Most of the times, you will be landing into a defective scenario. So, therefore, the huge number of data has to be there. The data population is very important here. So, big data is required, and then the data quality is also important. Data quality is important, and there should not be any bias, unbiased data, and the quality, high quality data. Okay, the data pre-processing of the data, some kind of noisy data can be eliminated. It's true, but but if the noise is more than the real life data, computer will not be able to this. They will not be able to. It will not be able to diagnose which one is true, which one is good, which one is bad. So high computing power requirements, that is another challenge. And then the privacy and ethical concerns I have already told you, the integration complexity. The integration complexity is very important in a actual physical manufacturing. To integrate it with the physical manufacturing system is a real challenge. Future trend is again the multimodal AI, vision transformers and multimodal AI, integration with AR, VR, augmented reality and virtual reality applications, Edge AI and 5G for real-time processing. These are the future trend, greater personalization and adaptability. So customization is really required. So ultimately, if you have a product diversification, then the same technology should be able to go for the customization for the product itself. Once that is there, that is the versatility has to be enhanced. So to summarize, what we find is that AI vision is a revolutionary industry, is a revolutionary issue in the smart manufacturing, and the applications spans from smart manufacturing to healthcare to retail to automotive as well as to security. Future developments promise even more intelligent and ethical vision system. So with this, I finish And I thank you all for your patient hearing. Whatever. Would you like to read my brief some thought? No?
Thank you, sir. It was a very interesting and very insightful session. All the techniques and all the soft computing skills that you have discussed in the session was very relevant for a modern time. Thanks a lot, sir.